Welcome to this session on BMPFast, presented by Dingbao Wang, Marty Wanyalista, Harvey Harper, and Ron Eaglin. This session covers how to enter data and interpret results within the BMPFast 2025 software, and includes assessment examples to reinforce your understanding of the learning materials. Whether you are working through this course to build your navigation skills, or you are a licensed professional engineer looking to earn continuing education units, this session is designed to support both goals. After viewing this learning module, you will understand how to perform analysis in BMPFast and be familiar with the full scope of the competency test. We'll walk through how to interpret the data used for BMPFast analysis and how to set up that analysis within the software. You'll also see an example of how to properly submit your BMPFast input and output for grading, along with the types of questions you can expect on the exam. We'll cover the structure of the test itself, including how many questions are asked, how retakes work, and what grade you need to earn your certificate of competency. The exam is designed to assess both your ability to use the BMPFast software and your broader understanding of stormwater management for water quality protection, specifically the annual removal of total nitrogen and total phosphorus mass. Let's start by walking through some example questions from the learning module quizzes. This first question asks what the acronym BMPFast stands for in its general national application. The four answer choices are Best Management Practices for Assessment of Stormwater Treatment, Basic Management Plans for Analysis of Stormwater Technology, Best Monitoring Protocols for Assessment of Surface Treatment, and Baseline Management Practices for Aquatic Stormwater Testing. A helpful way to approach this is to think about what BMP and FAST represent separately. BMP is a widely recognized term in environmental management standing for Best Management Practices. The FAST portion refers to the assessment of stormwater treatment component. Putting those together, the correct answer is Best Management Practices for Assessment of Stormwater Treatment. It is also worth noting that there is a Florida-specific variation of this acronym, where the F specifically references Florida, making it Best Management Practices for Florida Assessment of Stormwater Treatment. Here is the second example question from the learning module quizzes, continuing with the topic of retention BMPs. The question asks how treatment depth is calculated for a retention basin. The correct answer is that treatment depth is calculated by dividing the treatment volume by the catchment area. This gives you a depth expressed in inches over the catchment area, which is a useful way to normalize the storage requirement relative to the land area being treated. The other options are plausible sounding but incorrect. Multiplying catchment area by annual rainfall depth gives you a volume, not a depth in the way treatment depth is defined. The storage depth at the outlet elevation and the peak runoff rate divided by impervious percentage are also not how treatment depth is derived. The feedback reinforces that once you have your treatment depth, the applicant's Handbook Volume 1, Appendix O provides tables that adjust for pollutant removal, based on the curve number of both the non-directly connected impervious area and the directly connected impervious area. That said, you do not need to work through those tables manually, because they are all incorporated directly into the BMPFast model, which handles those calculations for you automatically. Here is question 3 from the learning module quiz. The question asks, if a wet detention pond is designed without a littoral zone, how must the calculated pollutant removal be adjusted? The correct answer is that the calculated removal must be divided by 1.1 to account for the approximately 10% reduction in efficiency. Field studies have shown that ponds with littoral zones achieve roughly 10% more pollutant removal than those without them. So when a littoral zone is absent from the design, you need to divide the calculated removal by 1.1 to reflect that reduced performance. It is a straightforward mathematical correction, but one that matters for accurately representing how the pond will actually function. The other answer choices are common misconceptions. Multiplying by 1.1 would actually overstate the removal. Not correct for the deficiency. A flat 20% reduction has no basis in the field data, and the idea that no adjustment is needed misunderstands the regulatory and performance implications of omitting a littoral zone. Keep in mind that the hint points you toward remembering both the percentage improvement that literal zones provide and the specific mathematical operation used to correct for their absence. On the competency test, you will encounter 20 questions like this one, so understanding the reasoning behind each answer is just as important as knowing the correct choice. Also worth noting, the BMPFast software handles this 1.1 adjustment automatically, so no manual calculation is required when using that tool. Let's walk through the first example problem using BMPFast, which focuses on a retention basin and comparing pre-development versus post-development nutrient loading. Retention basins go by several names. You may also see them referred to as infiltration cells, retention ponds, or infiltration basins. They can be used for both regional and on-site stormwater treatment. For this problem, the site is located in Marion County near Ocala, Florida. It covers 2 acres, receives 50 inches of annual rainfall, and sits on hydrologic soil group C soils. The pre-development condition is citrus land use, with a non-DCIA curve number of 80 and 0% DCIA. The post-development condition shifts to multifamily residential, keeping the same non-DCIA curve number of 80, but now with 28% DCIA. There is no limestone near the bottom of the basin, and field testing shows a limiting infiltration rate of 2 inches per hour. For the retention basin design, the site discharges to a non-exempt water body, meaning it is neither an outstanding Florida water nor an impaired water body subject to exemption. The standard design uses 1 inch of rainfall depth as the treatment volume, which works out to 7,260 cubic feet, or 0.167 acre-feet. With an average retention depth of 3 feet, the basin footprint area comes out to 2,420 square feet, or about 0.056 acres. There is also an option to double the treatment depth up to 0.333 acre-feet, though in this case there is no additional treatment volume available due to water table depth constraints. The BMPFast 2025 software will be used to analyze the 1-inch treatment depth. The goal is to calculate the treatment efficiency needed so that the post-development average annual nutrient loading equals the pre-development loading. That calculated efficiency is then compared against the percent reduction required by the performance standards for all non-exempt sites. Whichever value is greater, meaning whichever is more protective, becomes the required standard for the project. The analysis is set up for all sites non-exempt, using the net improvement option to calculate treatment efficiency through the pre- versus post-development comparison. The central question we are answering is whether the 1-inch retention basin size is sufficient to meet the applicable performance standard. If you have the software available, open it now and follow along to get the most out of this walkthrough. We'll start by filling in the general site information worksheet. Enter the project name, then select the meteorological zone for your project location, which in this case is Zone 2. Next, input the mean annual rainfall amount of 50 inches. From the Performance Standard of Surface Discharge Analysis drop-down menu, select the All Sites Non-Exempt option. For the groundwater discharge analysis, select Number. Once all of that information is entered, click the Enter Catchment button to proceed. Next, you'll move to the Watershed Characteristics worksheet. Here, you'll define your land use, and the software will automatically populate the event mean concentrations for nitrogen and phosphorus based on that selection. You'll then enter the catchment area, the non-DCIA curve number, and the DCIA percentage for both conditions you're analyzing. If your land use isn't listed in the available options, or if you're working with a mixed land use scenario, such as a disconnected impervious area combined with a soils area, simply select User Defined from the Land Use options. Once you've entered all the catchment data and click the Calculate button, click the back button to return to the previous screen. Now we'll enter the treatment options for our retention basin, starting with a design depth of 1 inch. The basin is designed at a maximum depth of 5 feet, which equals 60 inches. Using a limiting infiltration rate of 2 inches per hour, we can calculate the recovery time by dividing 60 inches by 2 inches per hour, giving us 30 hours. The design guidance then applies a safety factor of 2, which brings that recovery time up to 60 hours. For use with the retention efficiency curves found in the Applicant's Handbook Volume 1. Appendix O, the recovery time is set at 72 hours. It is standard practice to use a recovery time of 72 hours for retention basins, particularly for soils in hydrologic class A and B. This 72-hour recovery time is important because it aligns directly with the inter-event rainfall analysis used to develop those retention efficiency curves in Appendix O. This time value also sets a practical limit on basin depth. With an infiltration rate of 2 inches per hour, the maximum depth works out to 6 feet. To enter this in the software, click Enter Treatment and select the retention basin as your best management practice. The volume of the retention basin for this design is 0.167 acre-feet. After entering that value, click the Calculate button to generate your results and then click back to continue. Now return to the General Site Information worksheet and click the Configure Catchment button. In the Select Catchment Configuration worksheet, click the Edit button to specify the best management practice used for routing. From the Select BMP to Use in Routing drop-down menu, choose Retention. Once you've made that selection, click the back button to return to the previous worksheet. For this exercise, we are configuring the catchment with a retention basin that has a design depth of 1 inch. After setting up your configuration catchments, click the Full Routing button to generate the full routing report. This report becomes especially important when you don't have a validation code, because without that code, you won't have access to the summary treatment report or the complete report. The full routing report gives you a way to evaluate your treatment efficiency by comparing it against the all sites non-exempted specified percentage and the net improvement removal data. Looking at the results here, you can see that the 1-inch design depth successfully meets the all sites non-exempted specified percentage requirement. However, it falls short when it comes to the total phosphorus net improvement target. This tells us that while the design depth satisfies one criterion, additional consideration may be needed to meet the net improvement threshold for total phosphorus. Next, click Summary Treatment Report to view the results. This report gives us an overview of how effective the retention basin is at treating stormwater based on our 1-inch design depth. Looking at the findings, we can draw some important conclusions. The treatment does meet the removal requirements for the all sites non-exempt category, which is a positive result. However, it falls short when it comes to the pre- versus post-development total phosphorus removal requirement. So while the design satisfies one set of criteria, we will need to revisit it to address that phosphorus removal gap. If you need more detailed information beyond the standard output, you can click Complete Report to generate a comprehensive breakdown of the data. This report provides additional detail that's useful for further analysis or review. One of the practical benefits of this feature is that when a .bmpt file is submitted as part of a permit application, the complete report is already available to the reviewer. This means no additional time is spent looking up or compiling data during the review process, which helps streamline the permitting workflow. Now we'll look at the analysis result for the net improvement scenario, using the retention basin with a design depth of 1 inch. To get here, we need to go back and change one key setting in the model. In the General Site Information interface, switch the performance standard for surface discharge analysis from all sites non-exempted to net improvement. Everything else stays the same. Once that selection is made, click Enter Treatment to run the analysis with the updated standard. This allows us to compare the pre-development and post-development removal results under the net improvement framework rather than the standard non-exempted site requirements. When we select the retention basin option in the treatment options section and enter the retention volume, we can evaluate whether this design meets the stormwater management requirements. Looking at the pre-development versus post-development comparison, a retention basin designed with a 1-inch depth falls short of what we need. The requirement states that post-development average annual nutrient loading must be equal to or less than the pre-development loading, and this 1-inch design depth does not satisfy that condition. So we'll need to consider either a deeper design or an alternative approach to meet compliance. The results of our analysis reveal an important limitation with the 1-inch design depth. While it does satisfy the all sites performance standard for percent removal, It falls short when it comes to the total phosphorus pre-development versus post-development requirement. In other words, the post-development nutrient loading for total phosphorus remains higher than what was present before development, which means this design depth alone is not sufficient to meet the full performance standard. Because of this, we need to evaluate a deeper treatment retention depth. A 2-inch design depth has been selected for further evaluation to determine whether it can bring post-development nutrient loading down to or below pre-development levels. To do this, we return to the General Site Information worksheet and re-enter the parameters for a 2-inch design depth. All of the input data stays the same as before, with one exception. The project name is updated to reflect that we are now working with a 2-inch design depth. From there, we can run the analysis again and assess whether this deeper retention depth is sufficient to meet all applicable performance standards. Moving into the Watershed Characteristics worksheet, take a moment to verify that the same parameters as before are present and make sure all values remain unchanged. Next, click Enter Treatment and select the retention basin as your best management practice. Once selected, you'll need to enter the required data for this treatment option. For a retention basin with a design depth of 2 inches, the corresponding volume works out to 0.333 acre-feet. Go ahead and enter that value, then click the Calculate button to proceed. Now we'll repeat the same configuration process, this time for the retention basin with a design depth of 2 inches. Head over to the General Site Information worksheet and click the Configure Catchment button. From there, go into the Select Catchment Configuration worksheet and click the Edit button to specify the BMP being used. Clicking the Full Routing button gives you access to the complete routing report for the retention basin, which in this example has a design depth of 2 inches. This report provides a comprehensive breakdown of the routing calculations and results for the entire storm event. Looking at the Summary Treatment Report, we can confirm that the retention basin with a design depth of 2 inches satisfies all of the required treatment criteria. This report brings together the key results and validates that our design meets every requirement. The complete report gives you a more detailed breakdown of the analysis results. In this example, the output shows a retention basin with a design depth of 2 inches, which you can use for further review and more in-depth evaluation of your stormwater management design. Now let's look at the analysis report for the Net Improvement Retention Basin, designed with a depth of 2 inches. As discussed earlier, without entering the validation code and test code, users are unable to access the Summary Treatment Report or the complete report. However, by keeping all other parameters unchanged and selecting the Net Improvement option, you can view a direct comparison of pre-development versus post-development results. This gives you a clear picture of how the retention basin performs in terms of managing stormwater runoff relative to existing conditions. Now let's look at the analysis report for the retention basin, designed with a depth of 2 inches. To generate this report, go to the treatment options and select Retention Basin, then enter the retention volume that corresponds to the 2-inch design depth. Once you run the analysis, you'll be able to view the pre-development versus post-development comparison results. As the report shows, a 2-inch design depth is sufficient to meet the net improvement standard, confirming that this retention basin design achieves the required level of stormwater management performance. Here are 10 example questions to help you prepare for the BMPFast Project 1 competency test. Each question is multiple choice, and the actual test follows the same format, so working through these carefully will set you up well. The first question asks which meteorological zone applies, with choices of 1, 2, or 3. The correct answer is 2. For the specified removal of all sites non-exempt, you need to identify the nitrogen removal percentage, choosing between 55, 58, or 60. The correct answer is 55. For net improvement, the target nitrogen removal is either 55, 58, or 60%. Here the answer is 58. Next, you compare the multifamily EMC value of total nitrogen to the precondition value, determining whether it is greater or less. The answer is less. For the provided retention volume, you choose between 0.1671 or 7,260 acre-feet. The correct value to enter is 0.167 acre-feet. For the retention basin, the recovery time without the safety factor is either 3, 15, or 30 hours. The correct answer is 30. For the 0.167 acre-foot design, the mass reduction of total phosphorus in kilograms per year is either 0.66, 0.69, or 1.35. The correct answer is 1.35. Still working with the 0.167 acre-foot design, the discharge to surface water in acre-feet per year is either 0.44, 3.09, or 3.83. The answer is 0.44. For the 0.333 acre-foot design, the total phosphorus treatment efficiency percentage is either 22, 93.65, or 99. The correct answer is 93.65%. Finally, when allowed by local regulations, permeable pavement is indeed an option to increase removal, so the answer is yes. Let's take a moment to test your understanding of what we've covered. The following questions are single-choice format, so select the one best answer for each. Here is an example of how the grading system works in this course. When you submit a response, you will receive immediate feedback showing both incorrect and correct answers, so you will always know your grade and exactly what needs to be reviewed or corrected. The second example problem walks through a net improvement analysis using a wet detention pond. The scenario involves a half-acre wet detention pond serving a 5.5-acre highway expansion, where the road is being widened from 1 lane in each direction to 2 lanes in each direction. Importantly, the existing portion of the highway has no treatment system in place at all. In the post-development condition, both the existing and the proposed highway sections will be routed through the wet detention pond for treatment. The site is located in West Palm Beach, Florida, with 61 inches of annual rainfall and hydrologic soil group D soils, which are the least permeable soil group and generate the most runoff. For the existing condition, the highway has a non-DCIA curve number of 80 and a directly connected impervious area of 40%. In the post-development condition, that DCIA jumps significantly to 85%, with 4.675 acres of pavement. The wet pond itself covers half an acre and is not counted as part of the DCIA. The permanent pool volume is 2.472 acre-feet, and the design will incorporate a littoral zone. The key distinction for a net improvement analysis is that there is no fixed target removal percentage required up front. Instead, the goal is to determine how much nitrogen and phosphorus removal the wet detention pond must achieve so that the post-development average annual nutrient loading does not exceed the pre-development loading. In other words, you are calculating the treatment efficiency needed to offset the increased pollutant load from the expanded impervious highway footprint. We'll start by filling in the general site information worksheet. Enter the project name, then select the meteorological zone. For this project, we're working in Zone 5. Next, input the mean annual rainfall, which is 61 inches. From the Performance Standard of Surface Discharge Analysis drop-down menu, select Net Improvement. For the Groundwater Discharge Analysis option, select No. Once all of that information is entered, click the Enter Catchment button to move forward. Next, we'll move to the Watershed Characteristics worksheet. Here you'll define the land use and enter the key catchment parameters for both pre- and post-development conditions, including the catchment area, the non-DCIA curve number, and the DCIA percentage. For this particular problem, there is a wet pond area of 0.50 acres, which is not considered part of the DCIA. This means the total catchment area is 5.5 acres, and the wet pond area without loading is 0.5 acres. Make sure these values are entered correctly, as they directly affect your stormwater calculations. Once you've entered all the catchment data, click the Calculate button to process the values, and then click the Back button to return to the previous screen. Moving on to the third treatment option, Wet Detention. To work through this in the tool, click Enter Treatment, and select the Wet Detention Best Management Practice from the available options. Once selected, you'll need to enter the required data for this BMP. The permanent pool volume for this project is 2.472 acre-feet. If the project includes a littoral zone, make sure to check the box labeled Check if there is a littoral zone before proceeding. After entering that value, click the Calculate button to run the analysis. The results confirm that the wet detention design meets the requirement, meaning the post-development average annual nutrient loading is equal to or less than the pre-development loading, which is exactly what we need to demonstrate compliance. Next, return to the General Site Information worksheet and click the Configure Catchment button. This will take you to the Select Catchment Configuration worksheet, where you'll click the Edit button to specify which best management practice will be used for routing. From the Select BMP to Use in Routing drop-down menu, choose Wet Detention. Once that's selected, click the Back button to return to the previous worksheet. You can click the Full Routing button to view the full routing report, which will give you a complete overview of the routing details for your design. Next, click Summary Treatment Report to view the results. The report confirms that the wet detention BMP meets the net improvement requirement when comparing pre-development conditions to post-development conditions. The Complete Report section gives you access to more detailed information that can be used for deeper analysis and review. Here are the example questions for the BMPFast example test problem 2, along with the correct answers for each one. The first question asks which meteorological zone applies, with choices of zone 1, 3, or 5. The second question asks which analysis type should be selected in BMPFast for this scenario, choosing between BMP analysis, impaired water, or net improvement. The correct answer there is net improvement. Moving on, if there is no littoral zone, you are asked how many credits will be reduced as a percentage, with options of 5, 10, or 15%. The answer is 10%. Next, you need to identify the value of wet pond area without loading that should be entered in acres, choosing between 0, 0.5, or 1. The correct value is 0.5 acres. The fifth question asks whether the TN target treatment efficiency is less than what is required for an outstanding Florida water, and the answer is yes. From there, the questions shift to quantitative outputs. The mass reduction of TN is 11.19 kilograms per year, and the mass reduction of TP is 2.63 kilograms per year. The discharge to surface water after wet detention is 18.05 acre-feet per year. Finally, the TN treatment efficiency of the wet detention is 40.2%, and the TP treatment efficiency is 68.3%. Just as with Problem 1, these questions mirror the structure and format of the actual competency test, so working through them carefully is excellent preparation. Here's what you need to know about the competency test. The test consists of 20 questions total, covering 2 areas. Some questions focus on how to use the BMPFast software, while others are drawn from the learning material covered in the training modules. Once you register, you have 3 months to request the competency test, so there is plenty of time to prepare. After you submit your request to take the test, you have 48 hours to complete it. So be sure you are ready before requesting access. One of the more flexible aspects of this program is that the test can be repeated as many times as needed within your registration period, giving you the opportunity to demonstrate your competency without the pressure of a single attempt. And while you technically can go straight to the competency test as soon as you register, it is strongly recommended that you work through the learning modules first. The modules are designed to prepare you for both the software-based questions and the conceptual material, so taking the time to review them will put you in a much stronger position when you sit for the test. To earn your certificate of competency, you need to score at least 75% on the competency exam, which means getting 14 out of 20 questions correct. Once you successfully pass the exam with that score, your certificate of competency will be provided to you. Congratulations on completing the competency exam. A certificate of completion will be issued to you, suitable for electronic transfer and posting. Thank you for your dedication to this material, and thank you for watching. To earn the continuing education units offered through this course, you'll need to meet a few specific requirements. First, you must score at least 75% on the competency exam, which works out to 14 out of 20 questions correct. Once you pass that exam, you'll receive a certificate of competency, and 8 CS will be available to you, provided you meet the eligibility qualifications. Those qualifications are straightforward. You must be a licensed professional engineer in good standing. You also need to have completed all the course quizzes with an overall grade of at least 70%, And finally, you must have registered for the course and downloaded the required software. Meet all three of those conditions, along with the passing exam score, and you'll be fully qualified to receive your professional CS. By completing this course, you have joined a certified group of professionals who are equipped with the knowledge and skills to make a real difference in your field. Thank you for watching. That brings us to the end of these example competency test questions. The self-test you've worked through was designed by Dingbao Wang, Marty Wanyalista, Harvey Harper, and Ron Eaglin, and it reflects the types of questions you can expect on the actual competency test. Complete the competency test when you're ready, and you will be notified of your results. Thank you for watching.